Hello. So I don't have a key online for this. So I figured I would just make a video while I was making the key because, hey, why not? First of all, this is asking for the interval from 0 to 2 pi, 0 included, 2 pi not, exact form, which is the only way we've been doing this, basically unit circle stuff. So I need to get my trig function alone. This one's pretty straightforward. So I'll have 2 sine x equals root 3 when I move it over, dividing both sides by 2. I'll have sine x equals root 3 over 2, and I'll go to my unit circle and see where that is true. And so I don't have a unit circle here, so I actually have to think. It's annoying. Pi thirds, and then at 2 pi thirds. It doesn't ask for the general form. If it did, I would put plus or minus 2 pi n because it's a sine function. Okay, this one does have multiple angles, so I'm going to think about that. The n is a 2, so I take the normal cosine period, which is 2 pi. I divide it by 2. So this pi is going to be the spacing of my answers for later. Keeping in mind that I have to stay within this interval that they gave me. So I'm going to move the root 2 over first. And so that was a terrible 2. So this, I'm just kind of ignoring this 2x for now until I'm done solving. I'm going to go ahead and rationalize this since it's cosine. I won't be flipping it over. So it'll be root 2 over 2. But what I'm going to do is go to the unit circle and find where the cosine has that value. And that'll be my 2 theta or my 2x. And that, because that's what I'm solving for in here. So the places where it equals root 2 over 2 are at 4 pi. And then the other place the cosine is positive root 2 over 2 is going to be at 7 pi fourths. So then to get this alone, the x alone or the theta alone, I'm going to be dividing by 2, which is the same as multiplying by a half. So then my x is actually going to be pi over 8. And here it's going to be 7 pi over 8. So now's where you have to like kick in your actual brain and go, okay, I have to think about this a little bit because I know I'm supposed to add pi. I have 8's on the bottom, so that's going to be adding 8 pi over 8. But I also have to be mindful of my 2 pi limit, and my 2 pi limit is going to be at 16 pi over 8. So those are all the things I have to kind of think about. I'm anticipating 4 answers about probably because of that. I double that. So if I add 8 pi 8 to 1 pi 8, I'll get 9 pi eighths. But if I add another 8, I'd be at 17, which is too big. It's more than twice, like more than 2 pi. So on the bottom, I'm going to add 8 pi 8 again, because that was the spacing we found. And so that'll put me at 15 pi over 8. But adding it a second time would put me at 23, which is too big. So in the end, the 4 solutions that I expected are 1, 9, 7, and 15 pi over 8. Hopefully that makes sense. This one is also a multiple angles situation. I'm anticipating 6 answers. My n is 3. It's a sine problem, so the normal period is 2 pi. Dividing it by 3, this is what I'm going to be adding. That's the spacing between my answers. I actually don't have to solve anything. It's all solved already. So I just have to think about where on the unit circle is the sine 1/2. And one of those places is at pi over 6. And the other place is going to be at 5 pi over 6. It's a lot of thinking for my brain. Divide by 3, which is the same as multiplying by a third. Same as here. Bye-bye. So this turns into pi over 18 as one of my solutions. And this turns into 5 pi over 18. I am going to quickly run out of room, so I'll put the answers down below, the other answers. So now I have to think. This is my spacing, but I don't want a 3 on the bottom. I want an 18 for easy adding, so I'm multiplying that by 6. So I'll have to do the same to the top. So what I'm going to be adding to these is 12 pi over 18, but I'm going to keep in mind that my 2 pi limit with an 18 on the bottom is going to be a 36 on the top. So there's a lot of little things to think about when it's a multiple angle situation. Okay. So my first answer that I got was a pi over 18 When I add my spacing of 12, I'm going to be at 13 pi over 18. When I add that space again, of course, it's 25 over 18. But if I add that 12 again, I'll be at 37, which is bigger than my 2 pi. Going to my next option. The next option I got off the unit circle is 5 pi 18ths. I'm going to add 12 to give me 17 pi 18ths. I'm going to add 12 to land me at 29. And one more additional would make it too big. So these are my solutions. This review is not long enough. What the heck? Okay, wow, this one's kind of tricky. So I am going to rewrite secant, and I'm going to write that as 1 over cosine. So this kind of goes back to what we practiced a lot in the verifying. So this is over 1, and I need to be able to combine them to be able to solve it. Actually, you could do this a couple different ways, to be honest. One of the ways is what I'm doing. Another way is you could add this 1 over cosine x to the other side, so that if I did that, I'd be at 2 cosine x equals 1 over cosine x. And so then I would be cross multiplying basically. And that would give me 2. This is probably an easier way. In the end, they do the same thing. So I guess I'll show you both ways. Here I would multiply these and get 2 cosine squared x equals 1 as a cross multiplying. Here, if I would have gone ahead and gotten my common denominator, I would end up with 2 cosine squared x minus 1 equals 0. And then, I mean, here you're kind of thinking the same thing, cross multiplying, but 0 times anything will turn into nothing. So I'll end up with 2 cosine squared x minus 1 equals 0, which will lead me to the same thing I had over there, 2 cosine squared x equals 1. So whichever way you kind of see it first, and then I'll divide that by 2, and then I'll square root. And when I'm square rooting, I'm going to introduce that plus minus. So this turns into the cosine of x equals positive or negative the square root of 1 over the square root of 2, which will turn into the square root of 1 over root 2. So rationalizing that, I land here. So this is what I'm going to go find on the unit circle. And so any place that it's root 2 over 2. So that's going to be all of the pi fourths. So I'm going to have 1 pi fourth, 3 pi fourths, 5 pi fourths, and 7 pi fourths. So that is going to be the final solutions. And it doesn't matter to me which way you do it. That's why you show your work so I can follow along, make sure that it's mathematically sound. When I'm done with this, I'll upload this into the keys so you can see that as well. So here I have a sine squared, so I'm just going to start getting that alone by adding and then dividing by 4. I don't have a multiple angle situation here. I'm introducing a square root, so I'm adding plus minus over here. Here it just cancels, so it doesn't matter. And this is going to turn into plus or minus the square root of 1 over 4, which is going to turn into plus or minus 1/2. So I'm looking on the unit circle for where the sign has a value of plus or minus 1/2. And that's going to be in 4 spots, both at pi 6 and 5 pi 6. It's going to be positive 1/2. And then it'll be negative 1/2 at 7 pi 6, 11 pi over 6. And if you feel like you're always looking up or getting the same numbers, that's because so many of the numbers on the circle just are repetitious. All right, just glancing at this, I'm feeling like I'm probably going to have to factor. Think of it as 2y squared minus y minus 1. I feel like I did this in class. Maybe this was an example. So to get a 2y squared, I'll need a 2y times y. And to get a 1 at the end, I don't have any choices, 1 and 1. To get a negative 1 in the middle, I'll need this outside to be negative 2 and the inside to be a positive 1. If you're like mind blown still by factoring, then I don't even know what to do. So we're going to pretend you're not. I'm just replacing my y's that I was sort of using to give myself comfort. I'm replacing those back with the cosines that they were representing. So here I would need 2 cosine x plus 1 to equal 0. So I would I would subtract that 1 over and divide it by 2. And then I'd look on the unit circle for all the places that the cosine had a value of -1/2. And that's going to happen, here's me thinking really hard, 2 pi thirds and 4 pi thirds. Here I'm looking for where the cosine of x minus 1 is 0, which will mean the cosine of x has to be 1. And that's actually going to happen at 0 or 2 pi, but I'm not going to write 2 pi because my interval did not have 2 pi included because it had the bracket around 0 and the 2 pi was a parenthesis. Picky detail, but still a math fact. Okay, so here we're going to give all. What this is asking for is asking for those general solutions. I think the quiz makes it really obvious when to do that and when not to do that, so I'm not going to worry too much about that. So this is pretty straightforward. I'm going to go ahead and move that 1 over by subtraction, and I'm going to divide by 2. I'm going to go to my unit circle and see when that happens. I just looked that one up. So that's 2 pi thirds and 4 pi thirds. But since they're looking for the general equation, I'm going to add the period. And since this was cosine, sine and cosine, secant, cosecant are all 2 pi. Tangent, cotangent will be pi. So, and I'm going to do n times because you can add it as many times as needed all the way to infinity and beyond. That's it. That one was really straightforward. Okie dokie. This one also isn't terrible. 4 sine squared x equals 3. I move that over, divide out my 4. You can kind of see where these are going. You just got to get there, and you do need to show your work if you want points. It's only 5 questions. I think you can show your work. Then you're going to be on break. You're going to not even show any work for so long, till next year. You know, that joke just never gets old. So this is plus or minus the square root of 3 over 2. So there's obviously several places on there where the sign is square root of 3 over 2. First spot is pi thirds. I'm doing general or all possible equations or answers, so I'm doing that. The next spot that's going to happen is at 2 pi thirds. And 4 pi thirds and 5 pi thirds. Okay, so these came off the unit circle, and then in each case I'm adding the period 2 pi, adding or subtracting the period 2 pi any number of times. And that's if I'm asked for all or general solutions. This one's pretty straightforward also. The quiz does have, like, you have to think about some of them because there's only 5 questions, so you got to make sure that you are kind of game ready for that. Now I'm going to divide by that root 2. That's going to force me to do some rationalizing. Boo. But good thing I'm good at that, right? Or you are at least. Negative root 2 over 2. It's unit circle time. Okay, well, that happens at 3 pi fourths and 5 pi fourths. General solution, so plus 2 pi plus or minus 2 pi n. And again, it's cosine. If it was tangent or cotangent, I would be adding or subtracting pi n. Okay, so hopefully that helps you. Like I said, 5 questions. There's some tricky bits here and there just in terms of, I mean, things that we've seen, but there will be, you know, like cosecants on there. There will be tangent problems where you might have to do that, solutions, general solutions. So just make sure that you feel pretty confident about your solving and your use of the unit circle. And then you can go on break and it will be wonderful. Bye.